Hello everyone. Today we are going to analyze this frame using stiffness matrix method. Before analyzing, let us see the frame one time. In this frame, there are two columns, column AB and column CD. Also, there is a beam BC. In the column AB, there is uniformly distributed load 12 kN per meter acting for the full span. In the beam BC, there is a point load 20 kN acting in the center. In the column CD, there is a point load 27 kN acting at 1 meter from the point D. The moment of inertia for the span AB is I, for the span BC is 3I, and for the span CD is 1.5I. Length of the column AB is 4 meter. Length of the beam BC is 4 meter. Length of the column CD is 3 meter. In the points A and D, there are fixed supports. This frame is a sway type frame because the columns AB and CD are having different lengths. Now let us find the fixed end moments in the column AB. In the column AB, there is UDL 12 kN per meter acting for the full span. The formulas for the fixed end moments are minus WL square upon 12 and positive WL square upon 12. Here W is 12, L is 4. When we apply these values in the formulas, we are getting M of AB and M of BA. Now let us find the fixed end moments in the beam BC. In the beam BC, there is a point load acting in the center. The formulas for the fixed end moments are minus WL upon 8 and positive WL upon 8. Here W is 20, L is 4. When we apply the values in the formulas, we are getting M of BC and M of CB. Now let us find the fixed end moments in the column CD. In the column CD, there is an eccentric point load 27 kN. The formulas for the fixed end moments are minus WAB square upon L square and positive WA square B upon L square. Here W is 27, A is 2, B is 1. When we apply the values in the formulas, we are getting M of CD and M of DC. We know that this frame is subjected to sway. In this case, we have to find the horizontal reactions in the points B and C. But we have to be careful. These are not the real horizontal reactions. These are the reactions only due to the fixed end movements and the given loads. First, let us find the horizontal reaction in the point B, HB. Since in the column AB we have symmetrical loading, we can easily find HB. For that, we have to divide the total load by 2. Here the total load is 12 into 4. So 12 into 4 upon 2, we will get HB. HB should be acting towards the left side. Now let us find the horizontal reaction in the point C, HC. For that, I am going to take movement about D. In this case, I am moving towards the right hand side. Clockwise will be positive and anti-clockwise will be negative. HC is acting towards the point D in the clockwise direction. So it will be positive and the distance is 3 meter. So 3hc. The point load 27 kilonewton is acting in the anti-clockwise direction. So it will be negative and the distance is 1 meter. So minus 27 into 1. This movement is acting in the anti-clockwise direction. So it will be negative. This movement is acting in the clockwise direction. So it will be positive. Finally, we are getting hc. hc should be acting towards the right side. Now let us find the kinematic indeterminacy of the frame. In the joint B, there is slope theta B. In the joint C also, there is slope theta C. We know that this frame is subjected to sway. Let us assume that the sway occurs towards the right side. So the kinematic indeterminacy of the frame is 3. They are theta B, theta C and the sway delta. Now let us make the fully restrained structure. To make the fully restrained structure, we have to provide fixed supports in the points B and C. Now let us make the coordinates diagram. In the points B and C, we have the slope. So let us keep the first coordinate in the point B and the second coordinate in the point C. The third coordinate is the sway. Since the sway occurs towards the right side, let us keep this coordinate towards the right side. Now let us see the formula to find the displacements. Delta matrix is equal to K matrix inverse into P matrix minus PL matrix. In these three matrices, we will have three values because in this analysis there are three coordinates. Since we have three coordinates, the size of the stiffness matrix will be 3 cross 3. Inside the delta matrix, we will have the slope theta B, slope theta C and the sway delta. Now let us find the P matrix. We have made the first two coordinates in the points B and C. To find P1 and P2, we have to check the points B and C whether there are any movements. In the points B and C, there are no final movements developed. If there is overhanging, there will be movements developed. But in this frame, there is no overhanging. In this case, P1 and P2 will be 0. The third coordinate is the sway. To find P3, we have to look at the points B and C whether there are any horizontal loads. In the points B and C, there are no horizontal loads. So P3 will be 0. In this formula, now let us find PL matrix. Our first coordinate is in the point B. In the point B, we have found two fixed end moments, M of BA and M of BC. We have to add both of them. After adding, we are getting 6. Our second coordinate is in the point C. In the point C, we have found two fixed end moments, M of CB and M of CD. We have to add both of them. After adding, we are getting 4. Our third coordinate is the sway. We assumed that the sway occurs towards the right side. To find P3L, we have to add HB and HC. We have already calculated HB and HC. HB is acting in the opposite of the coordinate direction. We kept our coordinate towards the right side, but this reaction is acting towards the left side. So we have to apply this value as negative. HC is acting towards the right side. So this reaction is acting in the coordinate direction. So it will be positive. Let us add these two values. After adding, we are getting minus 17. In this formula, we have found PL matrix and P matrix. Now we are going to find the stiffness matrix. In the stiffness matrix, now we are going to find K11, K12, K21 and K22. To find them, we have to apply unit displacement in the first two coordinates. Then we can use the formulas. If the fair end is fixed, the formula is 4EI upon L. If the fair end is hinged, the formula is 2EI upon L. Now we are going to find K11 and K12. For that, we have to apply the unit displacement in the first coordinate. Our first coordinate is in the point B. So in the point B, I have applied unit displacement. In the point B, there was a fixed support, but we can assume that when we apply unit displacement, it becomes a hinged support, because in the fixed support, there will be no displacement. Let us see how to draw these curves. We are applying unit displacement in the point B. So from the point B, we have to make two clockwise curves, one curve towards the point C and one curve towards the point A. Then we have to see the direction of the arrows and draw these two curves. K11 should be calculated from the first coordinate. K12 should be calculated from the second coordinate. Let us find K11. For that, from the point B, we have to look other ends. First, let us look the end A. In the point A, there is a fixed support. If the fair end is fixed, the formula is 4EI upon L. Length of BA is 4. Let us apply that. Now let us look other end C. In the point C also there is a fixed support. So we have to apply the same formula 4EI upon L. Length of BC is 4. Let us apply that. The moment of inertia for BC is 3I. So instead of I, we have to apply 3I. For K11, we have to add these two values. After adding, we are getting 4EI. Now let us find K12. For that, from the point C, we have to look other ends. In the point D, there is a fixed support, but in the column CD, there is no slope curve. If there is no curve, there will be no stiffness. Now from the point C, let us look other end B. In the point B, there is a hinged support. If the fair end is hinged, the formula is 2EI upon L. Length of CB is 4. Let us apply that. The moment of inertia for CB is 3I. So instead of I, we have to apply 3I. Finally, for K12, we are getting 1.5 EI. Now, in the stiffness matrix, let us find K21 and K22. For that, we have to apply unit displacement in the second coordinate. Our second coordinate is in the point C. So in the point C, I have applied unit displacement. In the point C, there was a fixed support, but when we apply unit displacement, it becomes a hinged support. Now let us see how to draw these curves. We are applying unit displacement in the point C. So from the point C, we have to make two clockwise curves, one curve towards the point B and one curve towards the point D. Then we have to see the direction of the arrows and draw these curves. Now let us find K21. For that, from the point B, we have to look other ends. No need to look the end A, because in the column AB there is no curve. Let us look other end C. In the point C there is a hinged support. If the fair end is hinged, the formula is 2EI upon L. Length of CB is 4. Let us apply that. The moment of inertia for BC is 3I. So instead of I, we have to apply 3I. Finally, for K21, we are getting 1.5 EI. Now let us find K22. For that, from the point C, we have to look other ends. In the end B, there is a fixed support. In the other end D also, there is a fixed support. If the fair end is fixed, the formula for the stiffness is 4EI upon L. Length of CB is 4 and the moment of inertia is 3I. Let us apply them. Length of CD is 3 and the moment of inertia is 1.5I. Let us apply them. For K22, we have to add these two values. After adding, we are getting 5EI. In the K matrix, now we are going to find the third row. For that, we have to apply unit displacement in the third coordinate. The third coordinate is the sway. We have kept the coordinate towards the right side. So, towards the right side, we have to apply unit displacement. You can see that I have applied unit displacement towards the right side. When we apply unit displacements, we should remove all the loads. The formula for the moment developed due to sway is 6EI delta upon L square. Now let us find K31. For that, we have to find the moment in the point B due to sway. Since the sway occurs towards the right side, this moment will be negative. In this formula, let us apply the values. Length of the column AB is 4 meter. Let us apply that. The value of delta is 1. Let us apply that. Finally, for K31, we are getting minus 0.375 EI. Now let us find K32. For that, we have to find the moment in the point C due to the sway. In this formula, let us apply the values. Length of the column CD is 3 meter. Let us apply that. The value of delta is 1. Let us apply that. The moment of inertia for CD is 1.5I. So instead of I, we have to apply 1.5I. Finally, for K32, we are getting minus EI. The values of K31 and K13 will be same. Also, the values of K32 and K23 will be same. Now we are going to find K33. To find that, we have to add the horizontal reactions in the points B and C. The formula to find the horizontal reactions developed due to sway is 12 EI delta upon L cube. In the formula, let us apply the values. The value of delta is 1. The length of the column AB is 4. Let us apply that. The length of the column CD is 3. Let us apply that. The moment of inertia for CD is 1.5i. So instead of I, we have to apply 1.5i. After the simplification, we will get this. Then we can add these two values. After adding, we are getting K33. These two reactions will be acting towards the right side. We have kept our coordinate towards the right side. Since these two reactions act in the coordinate direction, K33 will be positive. In the K matrix, we have found all of the values. Let us enter them. EI is constant. Let us keep it outside. In this formula, we have found everything. Let us apply them. EI inverse is equal to 1 upon EI. For this matrix, we have to find the inverse. We can apply all of the values in the calculator and get the inverse. If you do not know how to find the inverse in the calculator, see the description below. There is a link. You can click the link and watch the video. I have used the calculator and got the inverse. We can add these two matrices. After adding, we are getting these. Then let us multiply these two matrices. After multiplying, we are getting theta B, theta C and delta. Now let us make the slope deflection equations and apply these values and get the final moments. First, let us make the slope deflection equations in the column AB. The column AB is subjected to sway. So, in the slope deflection equations, we have to add the moment due to sway. Since the sway occurs towards the right side, the moment due to sway will be negative. In the equations, let us apply the fixed end moments. Length of the column AB is 4. Let us apply that. In the point A, there is a fixed support. In the fixed support, there will be no slope. So, theta A will be 0. After applying the values of theta B and delta in the equations, we are getting MAB and MBA. Now let us make the slope deflection equations in the beam BC. First, let us apply the fixed end moments. For BC, the moment of inertia is 3I. So instead of I, we have to apply 3I. Length of BC is 4. Let us apply that. After applying the values of theta B and theta C, we are getting MBC and MCB. Now let us make the slope deflection equations in the column CD. The column CD is subjected to sway. So in the equations, we have to add the moment due to sway. In the equations, let us apply the fixed end moments. Length of the column CD is 3 meter. Let us apply that. The moment of inertia for CD is 1.5 I. So instead of I, we have to apply 1.5 I. In the point D, there is a fixed support. In the fixed support, there will be no slope. So theta D will be 0. In the equations, after applying the values of theta C and delta, we are getting MCD and MDC. In this analysis, we have calculated all of the moments. For MAB, we got a negative value. That means it is acting in the anti-clockwise direction. For MBA, we got positive value. That means it is acting in the clockwise direction. For MBC, we got a negative value. That means it is acting in the anti-clockwise direction. For MCB, we got positive value. That means it is acting in the clockwise direction. For MCD, we got a negative value. That means it is acting in the anti-clockwise direction. For MDC also, we got a negative value. That means it is also acting in the anti-clockwise direction. Now we are going to find the reactions. By taking moment about B, we can find HA. By applying the rule sigma H is equal to 0, we can find HB. Then by taking moment about C, we can find VB. Then by applying the rule sigma V is equal to 0, we can find VC. By taking moment about D, we can find HC. By applying the rule sigma H is equal to 0, we can find HD. Using the reactions and loads, we can make the shear force diagram. Using the formulas, we can make the free movement diagram. Using the direction of the end movements, we can make the end movement diagram. Then we can combine the free movement diagram and end movement diagram so that we will get the bending moment diagram. Now we are going to end this session. Thank you for watching this video.